All right, today we're going to look at solving systems of equations by graphing and also verifying using the equal values method. All right, here we're looking at our system of equations, y equals x plus 1, and our other equation, y equals negative x minus 1. So we have a set of equations that use the same variables here. All right, and we're going to first graph the lines of these two equations and determine their point of intersection. So we're going to use tables to graph here. So our first table we have for y equals x plus 1. List out some x values here, negative 1, 0, 1, and 2. And we're going to substitute these x values in to find the associated y. Here we go. Negative 1 in for x, so that's negative 1 plus 1 gives us 0. 0 in for x would be 0 plus 1, which is 1. And then 1 for x, that'd be 1 plus 1, which would be 2. And then 2 in the place of x would be 2 plus 1, and that would give us 3. So our coordinates we have is negative 1, 0, 0, 1, 1, 2, and 2, 3. So let's graph this here. So negative 1, 0, then 0, 1, 1, 2, and then 2, 3. Then draw a line passing through each of these points. And this is the graph of y equals x plus 1. All right, that's our line. All right, let's do the same thing here for y equals negative x minus 1. All right, again, substitute negative 1 in for x. So that's negative 1 would be negative 1, negative 1. Or negative 1, and that'd be positive 1. So 1 minus 1 will make that 0. Substitute 0 in for x. That'd be a negative 0, or just 0 minus 1, which will give us a negative 1. Substitute 1 in for x, and that's negative 1 minus 1 should be a negative 2. And then substitute 2 in for x. That'd be negative 2 minus 1, which would be a negative 3. So my coordinates I have is negative 1, 0, 0, negative 1, 1, negative 2, and 2, negative 3. So let's plot those points here. So negative 1, 0, which would be here. Then 0, negative 1, 1, negative 2. And then last but not least, 2, negative 3. Draw my line, pass through each of these points. And so this is y equals negative x minus 1. Now, determine our solution is determine where these points intersect. We look at this point here. This would be our point of intersection. Is where the two lines meet. And so here looks like our point of intersection here is at negative 1, 0. Negative 1, 0. So negative 1, 0 is the point that these two lines have in common. So this must be the solution to this system, y equals x plus 1 and y equals negative x minus 1. Now let's verify our solution here using the equal values method. All right, since we have both equations in y equals form, So we got y equals x plus 1 and y equals negative x plus 1. We have y equal to two different expressions, which means we can actually set these two expressions equal to each other. All right, let me rewrite them here. Y equals x plus 1 and y equals negative x minus 1. All right, but I said since both of these y equals to two different expressions, I can set both of these expressions equal to one another. X plus 1 equal to negative x minus 1. And now I can solve for x here. So I begin by, say, add x on both sides here. So here on the left side, it gives me 2x plus 1. X's cancels here, leaves me with negative 1 on the right side. And then if I add 1, both sides here, I get 2x. The 1's cancel to 0. Then I have negative 1 plus 1, which is also 0. Ooh, I messed that up.